All right, 30s, lesson 3 of polynomials. So looking at regressions to model data. And if I didn't say it last time, regressions are going to be big. We're going to do regressions in this unit, and we're going to do it in the next 2 units as well. And it's going to be a huge part of it. So it needs to make sense. You need to kind of practice it. So in a wonderful big box, life is just one big word problem. That's definitely how it feels all the time these days. So when given an equation, it is easy to graph and determine the x-intercepts or intersections of graph. Like we said in the last lesson, right? When we needed to solve, graphically is always in our back pocket, even if we're doing it algebraically by factoring or by the quadratic formula. But graphically is always there. But this case is going to be, oh shoot, it's fire drill time. Hang on. All right, I'm not entirely sure where I was because that was fire drill. So we'll just continue. So sometimes we're going to be given data points, like a table of values, and what we'll actually need to do is figure out the equation that best fits that table of values, right? So when we're given data points on a graph, trying to figure out the line that would best fit those. So we can create this line by performing what's called a regression. So it says here, for each of the following scenarios, draw a sketch that approximates the data given. So you have kind of a set of axes, go away, here for each of these scenarios. So it looks like a book sale, so how many books sold versus the revenue. This looks like a ball and where its height is after so many seconds. And then the last one is a time and velocity one. That's a little bit messy, but that's okay. So what I want you to do is pause the video now and draw yourself kind of a sketch for each of these. So this first one, your x-axis is going to be, this is x-axis, this is x-axis, this is x-axis, and the other is in your y direction, your y-axis. So this is going to be number of books sold, and this is going to be your revenue in cash dollars. So I want you to plot out what the graph looks like. Does it look like this? What does it look like? Whoa, this didn't go well. So plot that out, plot the next one out, again, with time being on your x-axis, height of the ball on your y-axis. So just do some little dots. And then the last one with time on your x-axis and velocity on your y-axis. So take a couple of minutes, plot that out as best you can, and then come back. Okay, so hopefully you're back. So we were just doing these graphs physically. And what we see, I didn't label all the numbers on there, but what it looks like is something like that. I only have 5 data points, but somehow I have 7 dots on there. I am magical. Then for the second one, so height of a ball versus time, it looks something like that. And the last one looks something like that. So if we try to apply this to the types of polynomials that we would see, this looks pretty darn linear. This looks like it could be a quadratic and that it would continue on in both directions. And this looks like a nice little cubic function. So what we're trying to do is figure out the equation for the line that would make, it won't let me erase, that would fit this data as best. So if I said, where will the ball be at 17 seconds? We don't want to just estimate based on our drawing. We can use the equation in order to solve something like that. So the little blurb that's actually below here is how you can actually plot it on your calculator, on the TI. There's a way to do it in the Casio as well. I can look that up for you. We just did it physically and that's perfectly fine. But in the TI, you can plot the data under your stat button. So you put in stat and then in your list 1, you would just put in your X values and in list 2, your Y values. Then you activate plot 1 on your Y equals. So where you would enter an equation up at the top, it says plot 1, plot 2, plot 3. You have to highlight one of those. And from there, you can look at what the data actually looks like. So there's some details there. I don't use it very often, but it's kind of nice to have. My caution to you is if you highlight plot 1, make sure you unhighlight it later because it will struggle later. If you erase the data, it will give you a hard time, or it'll just be plotting random dots on your information that you might not necessarily want. So now that we have an idea of what the graph should look like, let's perform a regression to determine the equation of each graph. You should learn the following steps. So the steps in here, again, are for a TI. All the TIs have a little bit of different things that pop up depending on which model it is. So I believe this is for the 84 regular, but it could be the plus. I don't remember, but it's going to be essentially the same. I have a little post-it note with regressions in Casio, so it has the information for how to do it. So in the TI, in your graphing calculator, you use the following steps. Oh, I guess I can scroll down here as well to look at it. So TI calculators are slightly different depending on the model. So you press Stat, Edit, and number 1. So we use this in statistics in 20-2, but now we're going to use it a little bit differently. So in Stat, Edit, and number 1, which is Edit again, you get L1, L2, L3 on the TIs. In the Casio, you press Menu and number 2, Stat. So on your main menu, number 2, Stat, and then you enter your datas into list 1 and list 2. So that's not too bad. From here, Casio, you can then graph it to see what your general shape would be. That's not too bad. So in the TIs, you press Stat, Calculate, and what we're going to do is we're going to be picking if we're doing a linear regression, that's the straight line is number 4, a quadratic regression, so that's your parabola, or a cubic regression. So you're going to press 4 for linear regression, 5 for quadratic regression, and 6 for cubic regression. So whatever matches your graph. In the Casio, so you press Calculate, which is F1, and select which type of graph. So X is your linear, X squared is quadratic, and X cubed is cubic. And then it gives you details for how to store the equation to pop it into Y1. That's kind of helpful if you have some really long decimals like we're going to see with one of these, but you can always just write them down and then type it into Y1 if we need it later. So that's the storing part there. Sorry, I'm just trying to read from here. So looking at those regressions that we had before, I'm going to just scroll down. I'm just going to use my key for this instead of my other one. So when we plotted each of those out, this is the best we're going to get for what it kind of looked like. And so I said on the last page, this one looks pretty much like a linear regression. This looks pretty nice for a quadratic. Oops. And this looks like a cubic one. So what I want you to do is following those steps, either for the TI or the Casio, put them in L1 and L2 for this first one. So put these in. So L1, put 25, hit enter, so it goes down to the next one. Then hit 50, press enter, then hit 75. Then scroll over to L2, and next to the 25, put 500. Next to the 50, put 1,000. So on and so forth. So you should have 5 sets filled out in total. I'm going to actually just do this really quick, but you should probably pause the video because I'm speedy fingers. So put it into L1 and L2 and then follow the steps. So we're going to try to do a linear regression. So in the Casio, you're going to do an X regression. In the TIs, you're going to do the lin regression. So again, you press Stat. You scroll over, come on in. You scroll over to Calculate. So it says Edit at the top, you scroll over to Calculate, and then you're going to scroll down to lin reg for this one. So number 4, lin reg AX plus B. You're going to press Enter. It might, oh, sorry, my calculator's doing something funny. It might then say on your screen lin reg A plus B. You have to press Enter for it to actually do the calculation. I can't remember on the Casio, you might need to press Enter after, or it might just give you your data points. And so when I press lin reg, what it says there is, again, our general form Oh, I don't have to write anything down. I forgot I'm using my key. On the calculator, it says ln reg y equals ax plus b, a equals 20, b equals 0. So my equation would actually be y equals 20x plus 0. Now do the same thing for the next two. So clear out all your data that's in there. Whoop, what have I done? This is not going well. Adobe. So in the next one, again, in L1, you've cleared out all your old data. You're going to put in 0 in L1 and 100 in L2. 5 in L1, 120 in L2, and so on and so forth. And then you're going to do a quadratic regression. So on the TIs, it's number 5. On Casio's, it's the x squared regression. And then finally, on the cubic one, that's your third set of data, you're going to complete the regression, and hopefully, maybe you should pause it right now so you don't see my answers again. Hopefully you get to the solutions that I have below for each of these. So in this case, I didn't really write it out all the way, but our full equation would be y equals a, no, not a, why would I write a? Of course it won't let me erase, y equals 0.9143x squared plus 13.8857x plus 92.2857. This is the equation, probably rounded to a couple decimal places, that best fits that data set. And then for my last one, for my cubic function, so I get a equal to 1, b equal to 5, c equal to 2, and d equal to -8 when we perform the cubic regression. So that's regressions. You have a whole slew of practice questions. I'll warn you that practice question 2, it's basically a long chart split into 2. So you see that you have years after 1979, 0, 1, 2, 3, 4, 7, then continue on 9, 12, 14, 17, 20, 22, and then match up accordingly. I guess I could show you instead of pointing at my sheet. But basically I didn't want to have a giant table. So this continues with this. So in total, you'll have 12 in L1 and 12 in L2, and then you'll need to either plot it out or plot it physically. I'm giving you all sorts of hints and you can see all my answers. But doing the regressions for each of them, I find that question 2 is sometimes kind of a tough one. And also watch, sometimes it'll tell you, like 4A says, determine the quadratic function that models this data. So it's already telling you to do a quadratic regression with that one. And then think through. So I would be checking your answers with my key as you do these, because again, regressions continue, and you need to be for reals good at it. So you've got a pretty good chunk of homework with this one. There's quite a few pages. Make sure you are completing these regressions and checking with my key to make sure that you know what's up. All right, take care guys. See you later.